So now we are going to take a look at some other key information that we can get from box and whiskers diagrams and 5-number summaries that is essential in analyzing data. So number one is what we call the range. So the range looks at the maximum minus the minimum. So what is the difference between the maximum and the minimum? Then here we would have 150 minus 50. So it would give us a range of 100. Then this tells us that there's 100 difference between the minimum and the maximum. Then we have what we call the interquartile range. This one gives us a more comprehensive understanding of the data because it focuses more on the middle section of the data. We'll talk about that and why is it important. So here we would have 79 minus 63, which gives us 16 for the interquartile range. So we would get our interquartile range as 16. All right. Now, here's the issue. When we look at salaries, for example, in South Africa, we find that there are people earning about 4,000 to 4,500, let's say, per month in the farms and other places where they work. So, then we look at the other side of it, the maximums, and then we find that there are people who earn about 6 to 10 million rand a month, perhaps even more than that, which are the CEOs of the big banks, financial institutes, and others. Now, when you look at the difference between those people, you look at the minimum, you look at the maximum, it's millions. Now, that makes it seem like South Africans are actually quite rich because we would say that, oh, the difference in salaries in South Africa is about 6 million, 5 million, 995, whatever thousand. But the issue is, this is not a true reflection of the population in South Africa. There is only a handful of people who earn those kinds of millions per month in a regular basis, that is. Now, so why are we then moving away from that? It's a similar situation that we saw here, that the 150 was so far ahead of all the other numbers present there. So it was affecting the data negatively in analysis. We call those kind of numbers outliers. They lie outside of the norm or outside of the trend that is in the data, which is why we prefer to work with what we call the interquartile range, because the interquartile range gives us a range of the middle section of the data where most of the population is at. So for example, in the middle section of South Africa, we would get around about, let's say, 20,000 for the upper quartile per month. And then on the lower quartile side, we would get about 6,000 based on the retail salaries where most people are at. Then when we look at the difference on that is that when you look at average people in South Africa, there might be about 15,000 rand difference in their salary per month. And then it would be more accurately true, 15 to 14,000, 10,000 or so. That will be true. Of course, we're not saying it's always like that. We're saying that generally when we look at the great population in South Africa, the difference in their salaries is more or less there. That would be a true reflection rather than saying that when you look at random people in the street or in the supermarket or in the mall, their salary could be in the millions in terms of difference. That would not be true. So that's what we look at in terms of data handling. Of course, now we have other measures that we can look at, especially for the sake of central tendency analysis and other key figures. Let's look at those ones before we conclude. Now, some other key indicators and summarization of data that can be given or that we have collected would be the mode. So we need to know what the mode is. So mode means that the most repeated value. So in our case, the most repeated value was 75 because there were 2 of them, whereas we didn't have any other number doubled or more than that or appearing more than that. Then after that, we have what we call the mean. Please remember, the mean can also be referred to as the average. It actually represents the average. In statistics, we call it the mean. So the mean is when you take the sum of all the data, so you add them all up together. So 50 plus 60 plus 63 plus 66 and so on all the way to the 150, which gives us 850. Then to get the mean, we would do 850 divided by 11, which gives us 77,27. So that would be our mean of the data. So the average here would be 77,7. We'll talk about it because if you look at it, 77,7 is actually way far ahead of most of the numbers. There's only 3 numbers bigger than that, and then that gives us 8 numbers less than that. And this is a result of influence of the outlier, that the outlier really changes things. However, this video is specifically about how to analyze the questions that have to do with standard deviation. The methods of how to calculate will be done separately. Now, first of all, let's talk about what is the standard deviation. Now, from the formula here, we see that the deviation is actually a sum, so it's a combination of or an addition of all the differences between the points that are given or the data values and the mean. So it's checking the distance between the point and the mean. And then it adds all of those distances and then divides by the number of values that are there. And then of course the rooting is then done, but it's just to get the variation properly. Now, in formal sense, let's say that standard deviation is a number that shows the average difference, which is what we call variations, of data values to the mean. So how far are the data values to the mean in general? So that's the kind of number we are going to be looking into. Then I'll explain how it's used. One of the easiest way to understand is when we are talking about the marks of learners, so that you can understand where did this 30% pass mark come from. Now, let's take a look at the marks of all students in general. Doesn't matter which subject we are talking about. We would be expecting an average of 50% because that's what an average student should be getting. Some will be more, some will be less. Now, the deviation is generally around 20%. We'll do another question that has to do with the actual finding of the accurate variation, but for the example purposes, let's take the standard deviation to be 20%. So the standard deviation, not just variation. That means that we are able to construct an interval called the standard deviation interval. Now, this standard deviation interval is done by looking at the mean minus the deviation number. Then the upper side is the mean plus the deviation number. So for the example that we have done, we would have a 50 minus 20, 50 plus 20 interval. To simplify it, it gives us 30% here and 70% on this side. Now, this is called the first standard deviation interval. So if you are asked how many values fall within one standard deviation, you will be looking at how many values are between 30 and 70. All of those fall within one standard deviation. Then if you are asked how many values lie outside of one standard deviation, then you would be looking at values that are less than 30 and those that are more than 70. They are outside. In some cases, they are specific to say that how many values are more than one standard deviation. In that case, we focus on the maximum, and numbers that are greater than the maximum are counted. If they are saying how many numbers are less than one standard deviation, we are looking at the 30, which is the minimum, and all the numbers below the 30. So we'll be looking at numbers below 30 in this case. That's how we do deviation. Let me just explain some applications of it. Statistics, especially when we do what we call the Maxwell-Boltzmann distribution curve, which is a curve that shows the distribution of a population, values, or data that can be collected in various forms. In this case, we're dealing with marks. So what we will be expecting is that there will be a lot of students. The majority will be around the 50s, right? Then there's this issue that when you do the first standard deviation, under statistic analysis, we know that about 68 to 70% of data will be in there. So what does the department know when it sees this? They would know that, wait a minute, this means that when an exam is written, about 70% of the learners who write the exam will get marks that are above 30 and below 70. Then we have another level of learners, same as the ones we are teaching, that are going to be getting more than 70% towards the 100%. So that's another group that's added to the 70. But the key is that we are left with about 15 to 20 maximum. 15 to 20% of the learners that would be below this. So this means that when the pass mark is at 30%, we are expecting that about 80% of learners will write matric subjects, subject by subject, please. 30% is not for the whole of the subjects, but in each subject, at least 80% of the learners must pass. That is why we can't accept a pass rate below 80% for nationals and provincials, guys. Really, we can't. So that is the meaning behind standard deviation. We do also have something called the second standard deviation. The second standard deviation, I'll just do it this way, is going to be calculated using an interval of mean minus 2 times the deviation, as well as mean plus 2 times the standard deviation. So if we look at the one we had, you will see that this actually gives 10, because it would be 20 times 2, which is 40. Then 50 minus the 40 is 10. Then this side we would get 90, because it would be 50 plus 2 times 20, which is our deviation, and that gives us 90. So statistically, we always expect about 95% of the data to be here. So that is what we call deviation. So deviation is a matter of how much of the data fits within a specific section for the analysis part, although the deviation itself is just talking about the distance of points of values away from the mean. But the type of analysis that we can do is this one, that we know under statistics that generally about 70% of the data values of any collected data set should be within one standard deviation. Then about 95% will be there, because you know as well as I do, for those of you who are out of school, you will remember this. There's always a few learners who go to the exam just to write their name, and they will tell you, I don't even know what's happening. And you're like, but it's obvious. And then they're like, obvious for you, but not for me. So we know there are those learners who get the very lowest zeros, ones, twos, fives, and all of that. We know them. But also we have the other side of it. As much as 95% of the learners are here, we do know that there are those that get 95s, 98s, and 100s. So those are also not counted in that 95%. So the 5% left over is made up of the highest achievers, as well as the ones that achieved the lowest. So that's what we have. This is what we call standard deviation. It talks about the difference that we have from the mean for the values. So it's a summation and then an approximation of or a calculation of the average distance of all the values from the mean. The questions that come about that, just to repeat them, how many values are within? So you'd look at your data values, because remember, you'd have the raw data spread out in numbers like we had in the previous exercise. Then you would be able to count how many lie between your first deviation interval. How many are outside? How many are less than? How many are greater than? That's what you need for your 5-number summary, mean, mode, median, range, and interquartile range calculation, so that you can go fly with flying colors past your data handling.